Okay, I think the recording will start. So, so with this background, so const is kind of an important thing as you develop bigger and bigger programs. It allows you to express more or provide more information to the compiler. So you can use the compiler. See, if you provide more information to the compiler will help you, debug your program better, future development. So other people who develop on the same program it will be easier for them, and so on and so forth. Okay. Okay, so with this, today's discussion is about a new feature which was introduced in C++, which was not there in C, which is the feature of reference. Okay. Um, so just a caveat here. So we will look at what reference is, etc. But you must have already seen the word or use of the term reference in the context of Java. Okay. Now, one thing I want to mention here is that Java uses so the reference is used in a similar context. Okay, in the sense that a reference is an alias for an object. Okay, so it could be it could be it could be an integer like a basic variable like integer, double, etc., or it could be an object that a user defined an object of user defined type which you have defined. Okay, so either we haven't gone to classes in C++, but you can also define using type def and struct. You can define your own objects. Okay, so yeah, so to that extent the two references are same, but the concept of reference in Java and the concept of reference in C++ is somewhat different. Okay, so you should keep this in mind while learning the concept of reference in C++. Okay, so we'll see what are the main differences. Okay, now so what is a reference? Okay, so a reference is an alias or synonym for an existing variable. Okay, so this is the first thing. So you look at this particular example here. So int I is equal to 15. This is a variable. Okay, now int %j is equal to I. Okay, this j is a reference to I. Okay, so just to recall, just to make the point clear here. Okay, what are we talking about? So I is a variable. Okay, now this I has a memory location, right? So this I points to a particular memory location. Okay, and this memory location has the content of the variable, which right now is 15. Okay, and if you see this address of I, okay, so you can access it via %I. Okay, so this is a little bit you can understand that. So when you are when you are getting an address of a variable through %I, okay, this is generating the address. But when you are defining a reference, you are also defining through writing the %j, and you are specifying the type. Okay, but here it is not like j is the address of I or something, or even I is the address of j. It is not like that. Okay, so yeah, so j is an alias or reference to I. Okay, now what does that mean? That means that for the entire program, J and I are synonymous. Okay, so wherever you can use I, you can use J. Okay, so yeah, so let us see this with an example. Okay, so here what we have done, we have defined this int a is equal to 10, and then we have said that this int ampersand b is equal to a, right? So basically this b is a reference of type int to and it refers to this variable a. Okay, so first you see, if you print a and b, obviously both print 10. Okay, if you print their address, so you can print the address of A and address of B. Okay, and both of them are the same address. Okay, okay. Now suppose you increment A and then print again. You see both A and B has incremented. Okay, you increment B, again the same thing happens. So it is like A and B are synonyms, so nothing changes. Okay, so they have the same address. Okay, if you
Sir,
yes,
sir, I did get this statement and B is equal to A. Like B is a pointer or means I am unable to understand this. What is B?
right. So you come back here. Okay, so ampersand can be used in two ways. Okay, it can be used in so one is when you are referring to address of a variable.
Yes,
Okay,
sir.
so this is ampersand I. Okay,
Yes, sir.
this can be assigned to a pointer variable or something like that. Okay, but when you are defining, so when you have a type and then ampersand and then a variable name, then what you are doing is you are defining a reference here. Here, so what
So,
are
sir,
you?
what is the data type of J?
Yes, come again.
What is the data type of J?
Okay, this question is not valid. Okay, so I will just tell you why this question is not valid, because J is not a variable. Okay, you can only have data type for a variable, right?
Yes, sir.
Okay, so clear why this question is not valid. Okay, so J is simply a reference. Okay, so I understand the question. So these are
Professor Shorangshu, may I
yes.
comment here? What you are explained is perfectly fine, but as a symbol, J has to have a type in C++, because
Okay,
every symbol needs to have a type, because there will be expressions where we'll use J. So the type
right.
of J is a reference to int, as we have written.
Yes,
We have written here. So it is reference to int, which means wherever int can occur, J can also occur. That is the
right.
basic difference with pointer, that it means the same variable. So reference to int and int will be coalesced in the same type in any expression, which is not true for pointer. So it may be better to look at it that way, because if we take that J does not have any type, then in an expression we will not be able to justify its presence.
Okay. Yeah. Yeah.
That is a contradiction we might get into.
Yeah. So yeah. Okay. Got it. Yeah. So it is so I will come to this in a bigger this thing, but okay. So J is not a variable. So first let us do this thing. So that J is not a variable. Okay, and you can think of the type of J as a reference to an integer. Okay,
So,
so
sir, no space is allocated to J.
no space is allocated to J. That is the main this thing. Okay, so separately J does not have any space. Okay.
Sir, what is the
Again
location
here,
of J, sir?
Professor Shorangshu,
Hmm.
this is a very tricky question that they are asking. Because there are two sides to it. If we look internally in the generated code, J is not an abstraction. J is a concrete concept. And to be able to refer to the variable, it needs to keep its address. So J has an address. But the difference is that is in the low level. But the difference is C++ does not allow you to take its address. So %J will always give you the same address as a I because it is the same variable. You cannot take the address of J. But in the low level, it has to have a memory location to, otherwise, how will it remember that it is I? It has to remember somewhere.
Right. Yeah. So,
in the low level, it will have, but that is not exposed. So as a programmer in C++, we will not be able to talk about address of J, and there is no reason to talk about address of J because it is nothing other than a different name for it. So for example, I'm Partha Pratim Das and PPD is my alias. So I have an address as A47. What is the address of PPD? Address of PPD is also A47, right? But somewhere you need to remember that PPD is actually Partha Pratim Das. So the concept of address gets a little different here in terms of the reference. It is just hidden from the high level. That will be a better way to use it for us. Okay.
Okay.
Hello, sir.
Yes.
Sir, after initializing I to 15 and associating J to I, in the later part of program, is there any way to distinguish between I and J? Like if we forget that %J equal to I is written in the above part of code, is there any way to distinguish between them?
No.
Like you told, they both will be used synonymously, right?
Yes.
So if I wanna pass this parameter to a function, like if I wanna pass the address of this parameter variable to a function, should I write %I or %J, or else are they both same?
Oh, we will come to that. So let's go ahead. Let's go ahead with how we will use this J. Okay. So see. Okay. So we will come to that. Okay. But essentially, like we mentioned here, there is no way to distinguish J from I in C++. This is the concept. Okay. In Java, you could. Okay. So in Java, you could have a reference to another. In Java, everything is reference, but you could have a reference to another variable, and then things could. So the reference has its own existence like that, but the way what Professor PPD said, if we don't go into the low level implementation for the time being, there is no difference between J and I. Okay, so it's a synonymous thing. Okay, so how do we use this? So the question comes that how do we use this reference? So you see, we have already used here. So B is another name for the variable A. And we have used it, so we can do A++, B++, wherever we do. So we can pass it to some function. Okay, we can do whatever. We can do arithmetic operations involving B, and it will look exactly same as A. Okay, so this is how you use a reference to a variable. Okay, so then the question will come, obviously, that why are we having this idea of reference? Okay. So so before we go there, these are some of the things that you can't do with references. Okay, so first is that you cannot simply define a reference without referring to something. Okay, so for example, you cannot say int %I. Okay, this is not a valid declaration, and so the reason is that I is not referring to any variable. Okay, but what you can do is you can say int %I equal to J. Okay, so this is correct. Okay. Now, another thing you cannot do is int ampersand j is equal to 5. Now, the reason this is not allowed is, see, this 5, okay, is a constant in the memory. So now we can come to the implementation part of it, what Professor PPD was saying. Okay. So when the program is, when the program is there, even the constants occupy some memory. Okay. So now, but as such, you don't take an address of a constant. Okay. So there is no address of the constant 5. Okay. But it is occupying some memory. Okay. So how do you define a reference to a constant? So the way to define that, so what C++ allows is you define it as a const reference. Okay. So you can say const int ampersand j is equal to 5. Okay. So this is valid. Okay. Because this is kind of a temporary. So in a sense, this 5 occupies some memory. Okay. But you are not, you are not allowed to access that particular memory. Okay. Or that particular address, for example. Okay.
Sir, so like I had a doubt. So basically, like in the first sentence, when we are declaring int ampersand I equal to j, so like in the low level, basically I stores the address of j, right?
No. It does not store the address of j. See, address of j will be accessed how? It will be accessed as ampersand j.
Yes, sir.
I is not storing address of j. No. I is a reference to j.
So sir, like as you and
say what you are saying in Java, you could say, okay, but in C++, it's a little bit different. It's only a name to that particular. So there are semantics which are defined, okay, on the different use of references. We will come to that one by one,
okay,
but
sir.
that statement is not correct that I is storing, the address of J. Understood?
Okay, sir. So like my doubt was like how is that information then stored that I is a reference to j? Like how will it be stored in the program, or like how will it be retained, like this information
Yes.
throughout the program?
So a lot of it will be resolved at compile time itself. So we will not go into the details of that. Okay. But what you will see is, for example, if you are simply referring to so you can think of something like this, right? So the moment you say int ampersand j is equal to I, okay,
Yes,
at the time of, so there are two times you have to understand. So this is a compiled language, right? So for example, the program could simply replace j with I. Understood? At compile time itself in this particular case. So I'm not saying that is how it is done, because there are lot of semantics which are lot of other semantics which are added to references. But so for example, this is how it could be resolved. Okay. So does that,
Sir, here in the third point, if we do later on print ampersand I, then what will it print?
you cannot do print ampersand I. That is the first thing, right? So you cannot. So if you try to print ampersand I, right? So
Yes, sir.
yeah, okay. So it will so it will print the address where this sort of this temporary thing is located.
But sir,
Okay.
this temporary memory may be used by some other variable later.
No, so that is what I'm saying. See, okay, so let me come to the third point. So we have, so the second point is clear.
Yes, sir.
Okay. So there is a, yeah. Okay. So see,
Sir,
if,
excuse me, sir.
yes.
Sir, in the second one, what will be the difference if we write only the const int j equal to 5 instead of writing m%? Because that will also be a work as a constant variable.
Yes, yes, yes. So j is a constant variable, but in that case, but in this case, j is a reference to a constant.
But sir, that is working like same like that in this case also.
Exactly. Yeah, yeah, yeah. Okay. So, so
Different ampersand j in the
that's what
second
we
case.
said, right? So, see, the j here is a synonym to a, so a reference is a synonym to a variable. So here j is not a variable, okay, but it is a reference to a constant which is there in memory.
So ampersand j doing ampersand j in the second case will give some address. Printing out that.
In the second case, yes. So it will give some address, yes.
Okay, sir.
Okay. So same. So we are also coming to the third case. So in the third case, you see the variable j here is a variable and the variable k here is also a variable. So now this j plus k, so normally when you do j plus k, so when let's say you do, so this j plus k is an expression which temporarily is computed somewhere. Okay. Now the fact that you are storing that you are storing a reference of that means at a later time you can access the value of this particular constant. Okay. So this will be stored somewhere in the memory. Okay. But this I will be a reference to this constant. Okay. So for example, that particular value you cannot change. Okay. So it's a value which you basically you cannot change that value. Okay. I mean, there are things you can do, but those will result in undefined behavior. So you should not change. Let me put it this way, that you should not change the value of this I. Okay. So this is a reference to a constant. Okay.
Sir?
Yes.
In the second and third cases here, we cannot change the value of j or I respectively. Like since it is we are declaring it as constant int.
Constant int ampersand, yeah. So reference to constant, yeah.
So what is its use, sir? So I mean, where can it be used if we declare?
Okay.
Instead, we can declare it constant int j equal to 5.
I will come to the most. So that is the question. Okay. So I have not told you the so one of the major uses of this construct happens in function calls, which we will come to next. Okay.
Sir, could you explain once the third one, like why is it wrong exactly, the wrong declaration part for the third case?
This one, right? So why is it wrong? Okay. So see this. So I can only be a reference to a variable, right? So if you have int ampersand I, okay, this can be only a reference to a variable. Okay, but this is not a variable. Okay. If we leave aside the implementation for the time being, this j plus k is not a variable. So for example, you can't say you can't change the value of j plus k. Okay, this is a value. That value may have some address. That value needs to be stored somewhere in memory. But as a concept, this is not a variable. This is not a location in the memory where you store things and then you retrieve things and then store something else like you use a variable. Clear? That is why you cannot do something like this. Because I will not refer to something. I will only refer to a value, not a variable. So j plus k is a value, not a variable. Clear?
So, sir, basically we are storing address of the final value of j plus k.
That is what I'm saying. So it is not like that. Okay. So think about the normal. So you are thinking about again the implementation detail, right? That, sir, if I take the address of I, then I can get the address where j plus k, that temporary value, is stored, right? That is how you are thinking. Okay. But the intended use is not that. Intended use is that this I refers, so it's a const reference. It's a reference to a constant, which is a temporary constant whose value is j plus k. Okay. And you can refer to that temporary constant through this I. That is the use of this. And we will see how this, how this works in the calling context. Okay. So what I will urge you to do is don't think reference in terms of address. Okay, because if you are thinking in terms of address, then the automatic question comes, why do we have reference when we already have pointers, right? So it is not like that. Okay. Okay, so let us, yeah.
So if we store reference to a constant in some other reference variable, so we can't say anything about the address, or can we say that the address of the constant stored in memory is same as the address of this reference variable?
If there is a constant, okay, and you have a const reference to that constant, you are not supposed to access its, because you are not supposed to access its address. So why will you need its address?
Understood, sir.
It's a understood. Okay. 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 So let us go ahead now. Huh? Okay. So now, the question was coming that why does C++ have this reference? Okay. So one of the main uses of this reference construct in C++ is what is called call by reference. So what is call by reference? So all of you, know a function call. Okay. So here we are calling this function under param test. Okay, so we are defining the prototype, and then we have this function has two arguments. The first one is of type reference to integer. Okay, this is allowed, by the way. Okay, so when you are defining it as a reference parameter, in the function, you can define something like int ampersand b. You don't have to say this is equal to something. It should, because at the time of calling of the function, you know that so you have to call this using a variable only. Okay, so that variable, basically this b will become the reference to this variable. Okay. Okay, and the second parameter, so I'll clarify this. So, and the second parameter is this int c. Okay, so this is a normal value parameter. Okay, now what happens? Okay, so so suppose in the function. Okay, yeah. So you are so in the calling, you are defining a variable a. Okay, and you are passing it both as reference here and as value here. So you see what happens. Okay, so in the main function, a was 20 and its address has been printed. Okay, and then we are calling the function and then testing. Okay, so b, which is referring to a. Okay, so a was passed both for b and for c. Okay, so b, which is referring to a, is 20, which is as expected. and its address is also same as the address of A, because B is a reference to A. Okay. But for the value parameter C, you see the value is as expected 20, okay, but the address has now changed because this call by value, okay, call by value parameter in C++, okay, what that does is that basically creates another memory. So you all know this. So this is the normal way of doing. So it creates another variable C in the stack frame, okay, and then copies the value of A to the memory location for this variable. But that is not the same for this guy, okay? So this is what the difference is, okay? So can someone tell what is going to be an advantage of this? So why should we try to pass by reference, and when should we try to pass by value?
So if you want to change the variable, you can.
Okay, I think many. Okay, so I vaguely heard two answers. One is that, let's say, when you are trying to change the value. So we will come to that. Yes, that is one use. But another use is that you see, suppose in this case, C is just a, A is just an integer. Okay, so we are just creating another copy of that integer, right? But suppose, A is a big structure, a big object or something. Okay, so then and suppose we are, we don't want to make a copy of it. We don't need to make a copy of it for whatever reasons. We'll come to all the things. Okay. So then you can also pass it by reference. In that case, it will point to the same object in the memory. So that is another use. Okay. So these are the two different uses of a reference. Okay. Passing by reference rather. Okay. Okay. So let us see an example for the first use.
So, will passing by reference also affect the running time of the program significantly?
Yes, we will come to that discussion. So as you can see, right? So if you are not, if you have some megabytes or gigabytes size object, and if you are making a copy of that object, okay, it is going to take some time, right? Okay. So in those cases, it is going to help. Okay.
Excuse me, sir.
Yes.
Sir, like when the function is called, so in the stack, there will be a memory location named C.
Yes, a new stack frame will be created, and there will be a variable named C. Right?
So, sir, B will not be there in the stack, right?
It will not be a variable. Yes, yes. So that is what I was saying, that it will not be a variable. So again, the two things, obviously B will be there because, at a low level implementation, B has to be tracked, but it will not be a variable in the, so it will not be a variable like that. So if you take, for example, so the thing that, has been done here, if you try to take the address of B, you will only get the address of, you'll get the address of A itself. Okay. 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 So, okay. So now this is the example where you say that suppose you want to change, in the calling function itself, okay, you want to change, sorry, in the function, you want to change the parameters, and you want the change to be reflected in the calling function. Okay, so an example of that is what we have shown here, which is the swap function. Okay, so what does the swap function do? Basically, it takes two inputs, okay, of type int, and it swaps them. Okay, and this is the code for swap. Okay, but in the call by value, you see your swap function doesn't really work, okay? Because what happens is that actually inside the function, 2 copies are created of the original variable. So when you come out of this function, the original variables are left unchanged, okay? And in C, you must have done this. So in such cases where you want to change the parameter inside the function, okay, and you want that change to be reflected in the calling function, okay, what you do is you pass by address, okay, address. So you pass the address of the original variable instead of the variable, and then you dereference that address inside the function to make the changes. So this is called call by address, okay? But you can do this call by reference, okay? So in call by reference, okay, you don't have to dereference because it is already doing the, so it is already synonymous to the original. So X is already synonymous to A. So whatever change you make here will be reflected in the calling function also, which, as you can see afterwards also, it is printing the swapped A and B. Okay. Okay. Now, yeah. Okay. So now this also has a disadvantage. What is the disadvantage? That, you know, since like we said, you may want to you know, call by reference, or you may want to pass parameters by reference, even if you don't want the original parameter to change, okay? And this could be mainly because of performance reasons, okay? Now, suppose, you know, then the question comes that how to do that, okay? So suppose you are designing a library and you want to pass your parameter by reference. So you want to give the functionality to the user such that, you know, the user is calling this function, okay? And he or she is passing the parameter by reference, but you don't want the user to be able to change this, okay? So sorry, so the user doesn't want whatever he or she is passing by reference to be changed inside the function, okay? So this is again a safe programming practice, right? So how do you do that? Okay, so the way you do that is by passing the parameter as a const reference. So in this case, you can see that what you are doing is you are passing const int ampersand x. So where x is basically a reference to, in this case, A, the variable A. Now, A is not a constant variable, but the reference here is constant, okay? So if you try to change X here inside the function, if you did not pass it by const reference, this would have been allowed. And in that case, in the calling function, this would have changed. Okay, so A value would have changed. A value would have become 11. Okay, but now this is not allowed. So this will give you a compilation error. Okay, of course you can return x plus 1, which is again a new variable that you are creating. Okay, so here in the right hand side code, there is no violation because you are not trying to change x itself. Okay, I hope this is okay. Yeah.
Sir, if we write like in the main function, after the function is called, if we write a is equal to 11, so will it show any error? Because
no. Okay. Okay. So good question. No. So only see, you are not making the variable constant. You are, so this is a good question. Okay. So see, you are only making x refer to a constant integer. Okay. So x is a reference to a constant integer, but a is not a constant integer. So a you can change. Okay. Okay. So let us go ahead. Okay.
Sir,
Yes.
Sir, the passing parameter is an integer and the function parameter is the reference to a constant integer. So does some type conversion take place, or like the reference to constant integer takes reference to the value of a, means exactly what happens at that point?
Right. So what happens is that you can at the time of calling, okay, so this is called, so you can bind a integer variable or a variable of type integer to a reference parameter. Okay, so basically what happens is you can so the way to think about it is that you can basically copy this so just like when you were defining the reference, what was happening? So you are basically making if you write int ampersand x is equal to a, okay, so you are making x refer to a, okay. Similarly, you are making x refer to a here. Now, a constant reference can always refer to a non-constant variable, okay, but the other way is not allowed. Am I making sense? So if you had, let's say, given here int ampersand x as the parameter, and you had tried to pass a const int a to int ampersand x, then that would have resulted in an error. Am I making sense here?
Yes, sir.
So I have a doubt. So if we are means passing like this and we are changing a means a equal to 11. So will x and a have the same address, or x will have a different address of the value of the a, means the a initially?
See, when are you changing a is equal to 11? Okay, so suppose you are changing, see, a is not visible to you inside the function. Okay, after you exit from the function, this x is not there anymore.
Sir, what if we define this x in the main function?
No, but we are only talking about the parameter passing here. So this is happening only when you are passing the parameter by reference. Is this clear? So you are basically defining the parameter as a reference. So at the time of calling, only a reference to the original variable is passed to the function. Okay, that is, so what you are declaring here basically is that only a reference to the original variable will be passed. It is not a copy of the original variable. Okay, so if you define the reference in the function, that scenario we have already discussed. Okay. Okay.
Means you said, sir, that we can means initialize constant with a non-constant. So if we do that in main, means then what will happen? Means the address of constant variable and non-constant variable will become different if we change the non-constant variable.
So you are saying what is the question? So so are you saying that so let me just, so are you saying that I'm trying to do something like yeah, so let's say const int I here. Okay, so let's actually come to the main thing. Suppose I try to say const int ampersand j is equal to I. Is that what your question is?
Yes, sir. And then I'm changing I, and then I'm trying to print the address of both the variables.
That will not be allowed. That's what I said. So const int ampersand j is equal to I will give a compilation error.
Okay, sir.
Sir, in my compiler, it is not giving compilation error. And I tried printing addresses are also same.
Yes, sir.
Sir, the I is also getting changed and J is also getting changed.
Sorry. So if you are saying const int ampersand j is equal to I, it is allowing you to change j.
Professor Shorangshu.
Yes, yes.
Ask them to paste the code on the comment on the.
Yes. Actually, that is better.
Because I mean, speaking code we cannot comment.
It's difficult to, yeah, it will take a lot of time actually to do. Okay.
When we say constant ampersand j equal to I, it only means that I cannot be changed through j. If we change I, it is allowed, and we can also, and so like that j will also be changed.
No, but you cannot assign to a constant reference a non-constant variable. If you did that, okay, so let me put it here. Okay, so okay.
Actually, you can do the reverse. You can assign a non-constant variable to a constant reference, because then that reference is constant. You cannot change the variable through the reference. The variable itself can change.
Yes, sir, that is what we did.
That you cannot set a non-constant reference to a constant variable.
Yes.
That will violate. So that is why I'm saying that it is. I mean, instead of saying just put the code in the comment section and then it is better.
Yeah. Okay. I think that is better. Yeah. Okay. So let us see. Yeah. So the next thing here is so not only can you call by reference, you can also return by reference. Okay. So what does this mean? So you please look at these two function prototypes. Okay. So the first one, it is taking a reference to an integer as an argument. Okay. And it is returning that particular that particular variable. But here the return type of the function is integer. Okay. So what happens here basically, and then in the function, in the main function, or what you are doing is you are basically assigning. So you are defining a const int ampersand b, and then you are assigning the return of this function to this const int ampersand b. Okay, so think about why the const is needed here. Okay, but we will think about that later. Okay, but the thing is, so now if you print b, okay, you see you are so you are getting the same value as a. So a was passed as the input and a is what is being printed as output. Okay, so you are getting the same value. Okay, but you see the address has changed here. Okay, so the address of b has changed here. Okay, so that means at the time of returning from the function also, there is a copy. So inside, when you printed the address of x, it was 0, the first address. Okay, after coming out, when you printed the address of b, it was a different address. Okay. But if we return, so now we write the same function in a different manner. We return by reference now. Okay, and we write the same thing. Okay, everything is same. Okay, when you print, you see whatever was the address of a, the same address was found inside the function, and when you returned and came back, the same address was found here. Okay. So, so what is going on here, right? So what is going on here is that you see this function evaluation is also kind of an expression. It's an can somebody is I think unmuted. Please mute yourself. Huh? Okay, so you see in this case, this particular function is an expression. Okay, so this expression is generating a temporary value. Okay, in this case, this temporary value happens to be the value of x, which was referring to a. So when x was there, okay, x was referring to a. So so in that case, you know, the address of x was same as address of a. But when you return it, okay, it is creating a copy of x. Okay, and this copy is in a temporary, it's in a temporary variable. Okay, so suppose you did not have, so two things. First of all, if you did not have a constant ampersand here, okay, you will get a compilation error, because if you remember, if you are defining a reference to a temporary constant, okay, which is an expression, basically a value, okay, according to C++, okay, then you have to define it as constant ampersand b. Okay, so this is the first thing. Okay, but in general, if you did not, if you just said int b is equal to you know, the function value, this thing, then what happens is basically this temporary value now gets copied to the variable b. So in that case, the variable b was there and it gets copied to there. Okay, so so this is what so this is what goes on. But when you return a reference, okay, even the return statement does not make a copy, but it returns a reference to whatever was passed here. Clear? Okay, so now as you can see in this particular code, this is very risky. So why is this risky? This is risky because what you could do is you could potentially define a local variable inside this function. To look at the right hand side here, you are defining a local variable t here, okay, and then you are returning t, okay, by reference. Okay, so what is happening here is that you are actually, whatever you are returning here, so that is a reference to t. Okay, but now this t has gone. Okay, so the original variable is no longer there. Okay, so so this can create problems. Okay, so you should be very careful not to do this. Okay, so you should not, when you are returning by reference, you should make sure that whatever you are returning by reference will persist even after the function exits. Okay, so
Sir, here this t is an integer, but we are return type is reference into int.
yes, so like I said, right, so so even so you can do that, right? So so an integer, so at the time of returning this so basically a reference to this integer t will be returned. What?
Okay.
So t is a local variable which will be destroyed after the function ends. So can we refer to an address which will be destroyed after that?
Yes, so that is why this is risky. So this is what I'm saying. This is risky. Okay, so this you should not do. Okay, so this is wrong. Okay, the left one is correct, but the so it you know so it may work sometime, but this should not be done. Okay.
So if we write ampersand t equals to x in that function, then if we return, then the value of a would be changed or not.
Sorry, come again.
Sir, if we write int ampersand t equals to x in the function and then return t, then would the value of a change?
If you write int ampersand t, okay, yeah. So if you write int ampersand t is equal to x, yes, this should work. Yeah, so this, because it will be a, but then yeah, so it will work. Yeah. Okay, because it's a reference to x and x is reference to a. So basically t refers to a. Okay.
Also, sir, like, can we
Sir.
change the value of b? Means when we are changing the value of b, the value of a would change in the first part written by reference.
So now, okay. So yeah, so this is the other thing, that when you are returning by reference, okay, what happens is that this kind of thing becomes, so you can make a statement, something like this, that return ref a is equal to 3. Now, normally, if you in C style functions, okay, this kind of statement would not be allowed, okay, because why would it not be allowed? Because you are trying to assign to a temporary value, because this returned ref a was always a value, okay. But now, because you are returning by reference, okay, this actually becomes a reference, okay. And basically the code semantics is such that you can just check for yourself that this will always refer to some variable, okay. And if that is the case, then whichever variable this function is referring to, this function call is referring to, so the function call is also an expression, as you all know. So whichever variable, so, and it is referring to some variable, okay, because it's a reference of non-constant type, okay. If that is the case, then you can actually do something like assign that some value, any value, okay. And that is legal because it is changing the referring variable. So this is kind of another use, you can say, of return by reference. Clear? Okay, so yeah, so this is just the sort of the summary of what we have discussed. Okay, so as a programmer, what you should do is you should so first of all, if you are using a value parameter, you can only use for the purpose of input, and the mechanism is call by value. Okay. If you are using a reference parameter, okay, then you can use it to do both input and output from a function, and the mechanism is call by reference. If you are using const reference parameter, okay, that means you can only use it for input, okay. You cannot change the const reference parameter, okay. But the mechanism is call by reference, so things can be more efficient if in certain cases, okay. And if you are looking at the return value, okay, and your purpose is output, you have two options. One is return by value. Again, you should use this option if you are sort of returning something small, okay, or you can return by reference, okay. But you have to be careful that the thing that you are returning by reference, okay, it should not be deallocated or should not go out of scope when you after you return it. Okay, so this can be used for various things. This return by reference. Okay, like we discussed. Okay, so any questions about this?
Sir, I have one doubt.
Yes.
In a function, if we declare a local variable and then we return its reference, means suppose we do that, then in the main function, will the means we in the main function we will assign this returned reference to some other reference. Then will it show an error, or will it be unpredictable output exactly what error will happen, or the memory address will change?
It is unpredictable, so it is undefined.
So means because when a function call returns, so the variable memory is returned back to the stack, if I'm not wrong. So how does means, and we are returning a reference to some local variable, so that's the doubt.
Yes, so so you know, so see, that's what I'm saying. So it depends on the compiler implementation, right? So it may happen, and it may also depend on the particular invocation. So it may happen that that particular memory, the stack frame is not immediately cleared. Okay, so in that case, you may be able to, for the time being, use that reference. Okay.
Okay, sir. But it is not a good practice to do that.
It is not defined. It is a bad.
Okay, sir.
Okay. Okay. So yeah, I think we have discussed all of this. Yeah, so there is this comparison with pointers. Okay, so you see, so in the beginning of the class, everybody was thinking about,
it is 111, Professor Shorangshu.
Oh, okay.
We have
So
the lab also.
yeah, maybe I will let you guys go to lunch, and we can start the discussion in the next class.
Sir?
Yes.
So I had a doubt regarding the software engineering assignment one. So like its deadline has been like extended as per you, but like in Moodle it still shows like today's deadline. So will you please update
I have
that?
not updated it in the Moodle. I will update it.
Okay, sir. Thank you, sir.
Okay, thank you. Okay.
Reference does initially when we create two ints, then we have defined addresses. When you return by reference, does the addresses become?
Sorry, I could not hear you. Hello.
Can you show the slide, first slide of return by reference?
This one, right?
Yes, sir. So please show the second one. Next one.
Okay.
So, sir, here does A and B have the same address? First program.
In the leftmost program, you mean?
Yes, sir.
No, right? So A and B should not have the same address in this case. Because, so can you tell why it will not have the same address?
Initially, they initialized.
Huh?
They had defined addresses that time.
No, because B is not a reference. B is a variable, you see? Is this clear?
Then what will be the utility of return by reference?
You see this particular invocation. Are you seeing this invocation?
Yes, sir.
Here, B is also a reference. So in this case, they will have the same address. So not in this case, the right-hand side case, this one.
I understood.
Okay. Okay, so thank you everyone then.
Thank you, sir.
Do we have a lab class today?
Sorry? Hello.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Sir, do we have a lab class today?
Thank you, sir.
We have a lab class, yes, yes.
Okay, sir.
Okay, thank you.